Dear students, when continuing the module 2 slop deflection method for the analysis of beams with settlement effects and overhanging effects. Moving on to the problem with settlement effects, analyze the continuous beam loaded as shown in the figure by the slop deflection method. The support B sinks by 10 mm. Take E is equal to 2 into 10 raised to 5 Newton per mm square and I is equal to 16 into 10 raised to 7 mm raised to 4. Then as I said in the previous lecture, the first step is step 1 fixed end moments. For the span AB, it is subjected to UDL, that means M bar AB is minus WL square by 12 and M bar BA is plus WL square by 12. Similarly as in the case of BC also, and in the case of CD, it is subjected to central point load, that means fixed end moment equation is WL by 8. Substituting these equations, find out the value of fixed end moments. Then you will get the values as minus 60 kilonewton meter, 60 kilonewton meter, minus 15 kilonewton meter and 15 kilonewton meter, minus 37.5 kilonewton meter and 37.5 kilonewton meter. Then what is the next step? Step 2 is slop deflection equation. Then as you know the slop deflection equation, MAB is equal to M bar AB plus 2EI by L into 2IA plus IB minus 3 delta by L. Before moving into the slop deflection equation, it is better to find out the value of EI in kilonewton and meter. So we can substitute directly the values here. So when you find out the value of EI, you know the value of PA E is given as 2 into 10 raised to 5 Newton per mm square and I is equal to 16 into 10 raised to 7 mm raised to 4. Then convert this to kilonewton and meter. Then by converting the values, then we will get 32 into 10 raised to 3 kilonewton meter cube. The value of M bar AB that you know that is minus 60 and L is equal to 6. EA is 32 into 10 raised to 3 and since A is the fixed one, IA is equal to 0, D is also fixed, that means ID is equal to 0, IA is equal to 0 and IB is there. Then what is the value of delta? In the case of AB, then you can look into the figure. Okay. In the case of AB, the support B sinks by 10 mm. The support B sinks by 10 mm means the right support is below with respect to the left support. As the sign convention, when the right support is below with respect to the left support, that means the value of delta is positive. So, we can written as minus 3 delta by L itself. The delta is 10 mm, so it has to convert it into meter, that's by 0.01. In the case of MAB and MBA, the value of delta is plus 0.01 meter. Then in the case of BC, when you take BC, since the support B sinks by 10 mm, that means when you consider BC, the left support is below with respect to the right support. As the sign convention, when the left support is below with respect to right support, that means that the value of delta is negative. That means the equation becomes this minus 3 delta by L. If delta is negative, that will be plus 3 delta by L. That means in the case of MBC and MCB, the value of delta is minus 0.01 meter. And ID is equal to 0, IC is unknown, IB is unknown. Substitute all the fixed end moment values, then we will get the equation number 1, 2, 3, 4, 5 and 6. Then after getting the slop deflection equations, the step 3 is joint equilibrium equation. The joint equilibrium equations here. What are the joint equations here? Then from the figure, here we are having 4 joints, joint A, B, C and D. Since the A and D are the fixed support, that means there should be some moments. But the joint B and C, In order to keep these joints in equilibrium, MBA plus MBC is equal to 0 and MCB plus MCD is equal to 0. We are having only two unknowns here since IA is equal to 0, ID is equal to 0. We are having two unknowns, that is IB and IC. In order to find out these two unknowns, we should have two equations. What are these two equations? MBA plus MBC is equal to 0 and MCB plus MCD is equal to 0. By using these two joint equilibrium equations, we can find out the value of IB as this and IC is equal to this. Substituting the value of IB and IC in the slop deflection equation of step number 2, then we will get the final moments like this. After getting the final moments, please draw the bending moment diagram. Firstly, draw the free bending moment diagram by considering this UDL, as that means parabola with the value WL square by 8. Here also UDL, that is also a parabola with the value WL square by 8. And this is the point load, that means WL by 4. Then mark the final moments. If it is in the anti-clockwise direction, that means that is negative. If it is in the positive, that means this is clockwise direction. Then likewise, please draw the combined bending moment diagram. Then, in order to draw the shear force diagram, find out the support reactions by considering all the reactions, all the external loads and all the final moments. If the final moments are negative, that means that is in the anti-clockwise direction. If the final moments are positive, that means the clockwise direction. Then consider all the external loads and by considering the equations of equilibrium, find out what are RA, RB1, RB2, etc. After getting the support reactions, by considering support reaction and the external loads, if they are in the upward direction, mark it in the upward direction. If they are in the downward direction, mark it in the downward direction. Then complete the shear force diagram. That is the case of settlement effects. The next is analysis of beams with overhangs. Considering the problem, analyze the continuous beam shown in this figure using slop deflection method. Then as you know, the problem is A, B, C, D. Then the first step is find out the fixed end moments. You know the equation. Substituting the equation, you will get what is the value of M bar AB, M bar BA, M bar BC and M bar CB. The only one thing you have to remember is that in all the other cases, the fixed end moment on the left support is negative and fixed end moment on the right side is positive. But when it is subjected to a couple of moments, both the fixed end moments are positive. And the equation is, one is MB into 2A minus B by L square, one is MA into 2B minus A by L square. Then substitute in the values, then you will get the fixed end moments. And the second step is slop deflection equation. In this case, there is no delta value. And the joint, when you consider joint IA is 0, that means A is fixed support, and you are having two unknowns, one is IB and IC. In order to find out these two unknowns, then the step 2, we will substitute IA is equal to 0, IB is there, all the fixed end moments you know, delta is equal to 0, then you will get the equations in terms of IB and IC. Then in order to find out, then how will you find out the unknowns? Then you are having two unknowns, one is IB and one is IC. Then how will you find out these two unknowns? You should have two equations. What are the two equations here? MBA plus MBC is equal to 0. That is the first equation. The second equation is MCB plus MCD is equal to 0. In this, MCD that can be substituted as MC is 5 kilonewton meter. MCB is 5 kilonewton meter. Then how will you get the 5 kilonewton? For this overhanging portion, the overhanging moment is 5 into 1 meter. This 5 into 1 meter, that is in the clockwise direction. Therefore, MCD means that the support resistance that will be in minus direction, in the negative direction. That means 5 into 1 is in the clockwise direction. That means resistance should be in the anti-clockwise direction. If MCD is minus 5 and MCD is in the anti-clockwise direction, in order to keep the joint C in equilibrium, MCB is in the clockwise direction. The overhanging moment 5 into 1 is in the clockwise direction. In order to resist this, MCD will be in the anti-clockwise direction. In order to keep this joint in equilibrium, MCB is in the clockwise direction. Therefore, MCB is 5 kilonewton meter, that is in the clockwise direction. In this joint equilibrium condition, substitute MCB is equal to 5 kilonewton meter and MBA plus MBC is equal to 0. You know the equation of MCB and you know the equation of MBA, you know the equation of MBC. So, you can find out what is EIIC and EIIB. Substituting the value of EIIB and EIIC in the slop deflection equation given in step number 2, then you will get the value of final moments. After getting final moments, please draw the bending moment diagram. Then find out the support reactions. After getting the support reactions, mark all the values, all the upward values in the upward direction and all the downward values in the downward direction and complete the shear force diagram. Okay, thank you.